Okay, Aanthur says he showed me 3 videos in which it is demonstrated that carbon dioxide is a greenhouse gas. Here again, I didn't see. That's alright. I have one called Linda's First Experiment. Does increasing carbon dioxide cause warming? At least I'm just with air and another balloon with carbon dioxide. Checks the temperature.
When we put the CO2 in, it was really cold, like ice cold. And the air was normal.
0.4 degrees Celsius. CO2 is at 37.6 degrees Celsius.
30 has a thermometer on at 8. And we're going to leave it there for a 37.8. And we're going to leave it there for a little while and come back and see which one's more heated up. We came back to the results, and CO2 is 41.9, and the air is 39.9. So the CO2 is warmer than the air, so my hypothesis has been supported by an experiment, so now it's a theory. Okay. See you, Dad. Thanks. Now what was I doing?
And 42.7 in the last frame. Camera. So in any case, it looks like the final temperature of the carbon dioxide gas was about 2.2 degrees warmer than the air. Let's kind of look at that in terms of Kelvin. The carbon, what is this? The higher temperature, the carbon dioxide was 315.7 Kelvin, and the air was 313.5 Kelvin. So the absolute temperature was about 0.7% higher for the carbon dioxide. Just to kind of play with this a little bit more, nRT is equal to pressure times volume is equal to, I believe it's R over C sub V times the internal energy of the gas. Not entirely sure where I'm going with this, but I just want to look at some of the other known factors about these two gases to see if I can come to some kind of conclusion, something a little bit more in-depth than just, hey, the temperature is higher. So here's the engineering toolbox. Graph that has the specific heat, constant pressure, and the specific volume. Carbon dioxide here, and we got nitrogen here, and we've got oxygen. And let's see if we could come to a conclusion as why carbon dioxide is absorbing, or is exhibiting more of its it's exhibiting a larger portion of its something as temperature. Like I said, I really don't know where to start with this problem, so let's start by kind of doing an estimation of the degrees of freedom. And I'm going to do that by setting this thing equals 2 over the degrees of freedom times U, which is degrees of freedom equals C sub V over R divided by 2? No, times 2. So in the case of carbon dioxide, this is the problem. This is given in kilojoules per kilogram Kelvin. I want it in, this formula is not going to work unless I've got it in joules per mole Kelvin. So I found a chart on hyperphysics which says that specific heat constant volume for carbon dioxide is 28.2, and this just says joules per Kelvin. That's kind of unfortunate. I would hope it was joules per mole per Kelvin. But I guess since I searched for molar heat capacity, so you can take for granted it's joules per Kelvin per mole. So that is really significantly higher than nitrogen specific heat capacity. And here they got that quantity C sub V over R that I was talking about. So basically nitrogen has 2.5 or 5 degrees of freedom, which is 3 linear and 2 rotational, while carbon dioxide has about 3.4 degrees of freedom. I'm sorry, more like 7 degrees of freedom. So that suggests that there's an extra couple of vibrational modes that are available to the carbon dioxide. It also might be the case that this specific heat is going to change, because you're going to, as you increase the temperature, carbon dioxide might go up to an R of 3.5 instead of 3.4. You see stuff like argon and helium are right at 1.5. That is because there is hardly any quantum mechanical effect. The quantization effects. This temperature is so high compared to the energy necessary to engage the linear modes of motion of argon and helium that they're basically 100% engaged, whereas there's some mode of motion of carbon dioxide that is only partially engaged. That there's not a 100% chance at this temperature and pressure. There's not a 100% chance of having one of its modes of vibration engaged. But kind of what I'm looking for is how does this, or does this extra degree of freedom in the in carbon dioxide, or extra 2 degrees of freedom in carbon dioxide, represent the ability of it to absorb more energy from the sun, because it's manifesting some physical property as temperature, and I think that temperature basically measures the nRT equals some kind of manifestation of the average kinetic energy of the gas. So what is it about carbon dioxide that causes it to gain more kinetic energy than, say, oxygen or nitrogen from sunlight and from the infrared light coming from the surface of the Earth, say. So I think, anyway, with a good concept of causality, we can address some of the denier's arguments more directly if I have begun to understand it. One of the arguments that I was just thinking of was basically, you come up to this point, you get a, 40.5 versus 42.7 with, I don't know what the percentage of carbon dioxide gas is in there, but this was a over here it was a 1 degree temperature difference, over here it was a 2 degree temperature difference. Anyway, it's about a 0.7% increase in temperature. But is this the worst it can do? Oh boy, carbon dioxide is just raising the temperature by 1 or 2 degrees. Big whoop-de-doo, right? Well, wrong. Or at least let me go through this thought process with you and see if you think that this is accurate. We've got carbon dioxide gas over here, and it is steadily happy to gain more kinetic energy from sunlight and infrared radiation, but it's going to pass that heat along to the hydrogen, the nitrogen, and the oxygen, and so it will actually, it might heat this stuff without this, so this stuff no longer has to absorb that radiation, and then once it passes that energy over to the hydrogen and to the regular air, then the carbon dioxide has lost enough heat, and it is ready to absorb more heat from the atmosphere to pass along to these things. Now, I actually don't know for sure that argument holds water or not. You see, I can make a hypothesis, and then it might turn out to be wrong because there's something I haven't taken into account yet. A lot of times I argue with myself, and usually I don't remember those things later unless I am happen to be recording it while I'm thinking about it. Right now I am kind of wanting to say that this idea is not going to increase the temperature beyond carbon dioxide's maximum temperature that you get from 100% carbon dioxide. However, I think we could, because of this phenomena of passing the energy along and then absorbing more, I think the temperature would increase asymptotically towards that maximum temperature. But what I don't think, you're not going to get CO2 levels like this and increasing temperatures like this. Instead, you're going to have, what do they call it, more of a logistic function, where you have something like this: no CO2 and high CO2. So some critical value over here, you just kind of pop up to this other temperature. It's not going to be an exponentially increasing temperature, but rather it's going to be a steady temperature that is about 0.7% higher absolute temperature than what you have with regular air. Well, I was going to run through the data on all three of the videos, but I'm kind of running out of time. This experiment was a little bit more carefully done, it looked like, and established 31.2 and 36.1 degrees Celsius. This was not done in direct sunlight, it was done under a lamp. And for that experiment, they got a 1.6% increase in absolute temperature. I'll bet the discrepancy is caused by that room exceedingly low humidity. Wait, let me look at water. Well, shoot, it looks like H2O isn't on here, so... Right, it couldn't be. Well, could it be on there? Data at 15 degrees Celsius in 1 atmosphere. Since water is a... Well, how do you handle water at water vapor humidity at 15 degrees Celsius in 1 atmosphere? Because water is not a gas at that temperature and pressure, so they can't really put it on this chart exactly. But anyway, what I've heard is water is just about as good as or better than carbon dioxide at absorbing infrared radiation and producing global warming. Now, this third video was a Mythbusters episode. I believe they got just a 1 degree change in temperature, and they had the whole place in a bath full of melting ice. So I kind of have a feeling that I'm not sure exactly. If you have a big chunk of melting ice in your experiment, that would mean that you have high humidity, right?
CO2 levels stand at around 350 parts per million, and methane,
that's the Earth CO2 level,
a tiny 1,800 parts per billion, but amounts.
That's 1,800 parts per billion is the amount of methane, and
they can up the greenhouse gas levels in minutely accurate increments. And once the gases are in, everyone can chill out and watch ice melt.
Let's start melting some Jamies.
M7.
Now, unfortunately, they don't tell us exactly how much carbon dioxide and methane are in these. I guess they're using the Earth's true levels of carbon dioxide and methane. So
24.8 degrees Celsius. The methane on 24.9. And both the controls were consistently a degree cooler.
I think that this is showing that CO2 and methane are major culprits for global warming.
All right, so the results from the global...
All right, so if this is the actual levels of methane and carbon dioxide in the chambers, then it looks like methane has all of the effective carbon dioxide and more by itself, even in that parts per billion range. So methane is a much greater concern than carbon dioxide at this point. Could be much greater. I haven't checked what its levels of well, I haven't seen some of the data on it, but I think it has a great potential for being pulled out of the ground in, say, for instance, the fracking that they've been getting really popular right now is, I think, producing methane. It's just being released straight into the atmosphere because they're not able to capture all of it that they're pumping out. It's just in so huge of a... They found such a wealth of natural gas down there. So far, my conclusion so far is maybe I'm missing something. Maybe the girl in the first tape didn't have 100% carbon dioxide. But if it was 100% carbon dioxide, then this suggests that we'll get maybe a 2-degree increase in temperature, or maybe only a 1 degree, depending on how much water is in this, because H2O is plus NOCO2 is going to be somewhere up here, and that would only be like a 1 degree increase if that's the case. Methane, is that CH3 or CH4? CH4, I believe, might be a more significant concern, though, depending on its maximum temperature.